All right. It looks like everyone is about here. So we can go ahead and get started. So let me go ahead and switch my share over. So hi, I'm Kevon Mayers. I am a solutions architect at AWS. And this is going to be an introduction to Terraform on AWS session. So we'll cover the main concepts of Terraform, things like resources, data sources, variables, things like that. There will be another section that you can follow for the hands-on lab portion. So let me go ahead and I'll switch over to my presentation. Okay, so again, I'm Kevon Mayers, a solutions architect here at AWS. So we'll touch on the problem. And again, this will be somewhat of a recap to a lot of you guys, but basically, organizations have a desire to modernize and enable rapid innovation. They also would like to add scalability for new and existing workloads, and also to streamline deployment and management. Then we'll get into a little bit of an AWS recap. So how your workloads can be deployed manually versus programmatically. And then we'll get into the solution, infrastructure as code, so a high level overview of that, and then a overview of Terraform. Then we'll switch into the core concepts of Terraform. And then we'll also have, like I mentioned, a hands-on workshop for building a WordPress site on AWS with Terraform. There's a dedicated Q&A section, but as always, I'd like to have these as dynamic as possible. So if you have a question, feel free to just put it in the chat, and we'll go ahead and address that, or just come off mute. We want to make this where everyone feels they're heard here. So learning goals. By the end of this workshop, you'll be able to understand the ways you can deploy workshops to AWS, so that manual versus programmatic methods that I was talking about. You will also understand what infrastructure as code is and some of the main benefits. You'll also understand what Terraform is, how to use it on AWS, as well as the basic concepts such as providers, resources, data sources, modules, and Terraform state. And then in the workshop, you'll apply this knowledge to deploy a WordPress site to AWS with Terraform. So at a high level, let's just cover this, right? Industries want to modernize, and for a variety of reasons, right? So increased performance, efficiency, the enablement for rapid innovation, and then also decreasing costs. So this leads a lot of organizations to want to go to the cloud. The cloud is nothing more than a virtualized network and a series of data centers, and there are cloud providers like AWS, Azure, GCP, etc. They all have their own flavors of cloud, which all have some nuances, but they all boil down to the same core technologies as on premises. You have compute, storage, and networking. So you're going to compute something, you're going to store the relevant data, and then you're going to transmit that data between systems. So for the recap of AWS, as I'm sure most of you, in the call and watching this later, familiar with what AWS is. But really what it is it's a cloud provider, and what it really enables you to do is via a variety of services, which I like to refer to as building blocks like Legos. Basically build out your workloads in a very scalable fashion. So the categories of services are vast, but they include technologies like compute, storage, networking, IoT, AI and ML, things like that. Just an example of some services here. So let's talk about deploying resources, right? We recapped a little bit about what AWS is and some of what's at your disposal. So now let's talk about how you can actually deploy some of these services or these resources. And this really comes down to two main options. You have the AWS Management Console, which is basically, you log in and you have a graphical way to kind of create these resources. And then you have Programmatically. So this would be using things like the CLI, AWS CLI or command line interface, SDK, the software development kit, etc. All those kind of things would be programmatic. So let's take, for example, Amazon S3. Amazon S3, or also commonly referred to as just S3, is an object storage service. And, so let's just look at what we're doing here, right? We're creating a bucket. We enter the bucket name. Now we would go through and, set some specific parameters for the bucket, and then click create. But what actually happens when we click create? APIs everywhere. This is probably an oversimplification, but at the end, goal or in the end state, some sort of API is being invoked to actually create that bucket. So in a more visual way, let's take, for example, this, right? We entered things like a name, we set a region, we had some different attributes, block public access is set to true, etc. Now, this is not exactly how it actually would look in terms of the data structure, but just as an example of some JSON information, right? Same thing, you have the name, resource type, encryption, all these kind of things. Basically, what you're entering would be converted into a format that the API can consume, and then the backend logic would happen to actually create that resource. So, you're not actually going in and provisioning and managing the underlying infrastructure that S3 uses. You're just interacting with it via some sort of an API, even if it's abstracted away via management console, SDK, CLI. Under the hood, that's what's happening. So let's look about it programmatically, right? If we were going to use the CLI, so simplified command for making a bucket with the same name in the same region, again, would map down or boil down to some sort of data structure that the API would be expecting, and then that would actually go invoke the actual underlying infrastructure that makes that resource. So let's talk about what an API is. This might be a refresher for some of you, but an API is really just an abstraction layer that allows entities to talk to each other. So things like you have some items in a cart and you want to check out. Well, that's an API interaction most likely. Uploading a file, shipping an order. API standing for Application Programming Interface. And let's look at a visual example to kind of understand this a little bit more. So let's take this example of a user who is saying, I would like a bigger than your head burrito and a drink. And they're going to tell that to the API. The API is going to say, great, sure thing. Send that information to the application. Application will then acknowledge that, was going to actually make that bigger than your head burrito, pass that back to the API, and the API will then feed you or give you that burrito that you requested. All right. So with that out of the way, let's talk about infrastructure as code. And infrastructure as code is the managing and provisioning of infrastructure through code instead of through manual processes. And a main benefit you get with infrastructure as code is repeatability. So my DevOps methodology is that if you do something once, you're probably going to have to do it again at some point. So you might as well automate it. There's some exceptions to that. Sometimes it's a trade-off. Is it really worth writing this, kind of long automation that makes it just a little bit easier? But in general, the whole main thought process behind DevOps is automation and things like that. Manual processes can work, but they're not always the most efficient way about going about accomplishing your tasks. There's also the risk of human error. So we all make mistakes, and with manual processes, that can be even easier to happen. So take for the example from earlier. What if you accidentally created a bucket with the incorrect name? Well, you would need to then delete the bucket and then create another bucket with the correct name. So there's that manual process. So let's take, for example, imagine that your manager tasked you with creating 1,000 EC2 instances that all have identical configurations. That might leave some of you looking like this and feeling this kind of way. So what are your options? You could walk through the EC2 launch wizard 1,000 times, but I personally wouldn't wish that on anyone. And there are many other ways that you could more effectively and efficiently use your time. So with infrastructure as code, you could simply define the desired configuration of the EC2 instance or any other resource that you want to create and configure the code to execute 1,000 times. And while the code is running, you're freed up to do other things like grab some coffee, take a little break. Okay, so now that we talked about infrastructure as code, let's focus on Terraform, which is one solution for infrastructure as code. And what is Terraform? It is an infrastructure as code tool that lets you build, change, and version cloud and on-premises resources safely and efficiently. So if we look at this graphic, let's see what's really happening here, right? We have Terraform, and then we have something called a Terraform provider that we'll touch on later, and then a target API. So in the case of AWS, right, we would have the target API being our service APIs. So we would define our Terraform in our configuration files, which we'll kind of show that a little bit more later. Then we have a provider, and the provider is basically the abstraction layer that talks to the APIs on your behalf. So say you say, hey, I want to make an S3 bucket, and that's in your configuration. The provider is going to see that and say, hey, AWS API, I need you to make an S3 bucket based on this configuration. Okay, and in Terraform configuration, it's written in something called HCL, or HashiCorp configuration language. It's based on the Go programming language, if you're familiar with it. And basically, these configuration files for Terraform, they tell Terraform the plugins to install, i.e., so like things like providers, what specific infrastructure to create, and what data to fetch. You might also be familiar with the AWS Cloud Development Kit, or CDK. It's another infrastructure as code tool, and a similar solution for deploying resources could be achieved using that as well. However, there are a few reasons why many customers choose Terraform, and why, in my opinion, AWS is starting to embrace it more. So first one being customer obsession, right? One of the leadership principles, and many customers primarily use Terraform. Prior to joining AWS, I worked as a DevOps engineer at an AWS partner. Almost every single customer we worked with was already using Terraform before we even onboarded with them. And there's been a few AWS solutions I've helped build where the resounding feedback was, this is great, but we would have loved if there was Terraform support. Some customers also desire multi-cloud deployment, and with Terraform, they can standardize their infrastructure deployment. The next reason is modularity. So Terraform really shines in this area, and it was built to be cloud agnostic and to really have the ability to incorporate any resource. So they have the concepts of modules, which aligns directly to that modularity, and there's also a concept of providers, right? And this is really how another way the modularity is accomplished with Terraform. Providers are basically plugins that implement resource types, and you can add virtually any resource by adding providers to your configuration. Don't worry if that's a little confusing right now. We will touch on providers in a dedicated section coming up. And then we have drift detection, right? So this is native to Terraform, but some customers have mentioned struggles dealing with this in CDK and CloudFormation. So if a resource managed by one of those tools like CDK, CloudFormation, if something is created outside of that, it won't actually natively detect the drift and correct the change. So this is, at least as I last recall, at the time of you watching this recording, this might be different, but at least, at this point in time, this is one of the main reasons I've seen for why a lot of people kind of gravitate to Terraform, amongst other things. But drift detection is definitely a pro for a lot of people. Okay, with that, let's cover some of the basics of Terraform that we'll get into. So we'll touch on things like folder structure, local values, input variables, output values, providers, resources, data sources, state management, and then we'll also briefly touch on how you can use the Terraform documentation. So folder structure. Take, for example, you have a project that is, the folder is called My Terraform Project. Within that, you have a couple of files. So you have your main.tf. This would contain the core resources of the module. And again, we'll touch on what modules are later. We have outputs.tf. This would contain the outputs of the module. Variables.tf would contain the input variables of the module, and providers.tf would contain the provider configuration, which again, we will cover later. It's important to note, these are not, in general, not hard and fast, like you have to call everything these specific names for it to work. As we start to get into when we touch on what resources are, You could, actually create, say you want to create an S3 bucket or an IAM role or things like that. Instead of putting them all on main.tf, and really increasing the number of lines of code, you could start to separate that out and say, okay, well, I have main.tf for more general things, but maybe I want an IAM.tf. Maybe there's a lot of IAM resources that you want to make and you want to group them so they're easy to find. Or there's a lot of S3 buckets or, things like that. So you can, separate it out. And in general, though, you just want to follow some good naming conventions. So now let's talk about providers. Providers provide interactions with cloud providers, SaaS providers, and other APIs. And each provider provides a set of resources and data sources that Terraform can manage. So let's take this code block for an example. We have a provider of AWS. The region is US East 1. So, this is the general syntax that you'll see for Terraform. You have, whether it be a provider or a resource or a data source or a variable. And then you have, like a local reference to it, in this case for the provider. And then you have like this attribute for it. And then that's going to be enclosed in curly braces. It's important to note too, there are actually two AWS providers at the time of this video at least. There is the AWS provider, and there is also the AWS CC provider. CC standing for Cloud Control, which would use the Cloud Control API. I'll post some more references in the chat to that if you're not familiar, but basically it was created and announced, I believe, at reInvent 2021 to really streamline the integration for customers and partners to really standardize the API. So, with the standard or the regular AWS service APIs that people would use, there could be different syntax to accomplish the same thing. So describe instances versus list something, which functionally would provide, do the same thing, but that's standardized in the Cloud Control API. So just wanted to touch on that. Vast majority of things we'll be doing in Terraform, at least at this point in time of recording, we'll be using the AWS provider, but increasingly the AWS CC provider is starting to, have a focus. Okay, so now we'll talk about resources, and resources are the core element in Terraform. And declaring a resource can define one or more infrastructure objects, so things like compute, storage, networking. So take, for example, an S3 bucket. You can see here, similar to like the provider and the general structure as in being in these curly braces, we have a resource, and then we have AWS underscore S3 underscore bucket. And then we have this example, right? This is the local reference to this resource to be used somewhere else in Terraform. So this could be called example, this could be called tomato, this could be called, whatever. The idea is that this is how you can directly reference this specific resource and the attributes that are within this resource. So you would generally in production, you would want to name this a little bit more descriptively so you can find it more easily. But so you can see in this case, this is actually the bucket name, that we'll be creating, and this is just the local reference. So that's that, the difference. There are also, you might be thinking, well, okay, well, if I need to make 10 buckets, do I have to copy and paste this 10 times and then, just change the name? No, there are actually ways that you can reuse code and essentially loop through your resources. It's more of an advanced topic. I'll post some references or links for you to read up more on it. But with Terraform, they basically have these arguments that are called count or for each. So count basically is as it sounds, right? Imagine if you want to make 10 EC2 instances, you can define that all have the same configuration, like the example we talked about. Define the configuration in this case, it would be a different resource that maps to a AWS underscore instance. But then you can put an attribute that says count equals 1,000, like in the example. Then what that would do is actually make 1,000 of those specific resources. For each is a little bit different. That's kind of when you get through wanting to have more complex data types, which we'll touch on, but things like objects or maps for where you want to have a different configuration for each map that you have. But again, that's a little bit more advanced, but we will briefly touch on it later. Okay, so we talked about resources. Now let's talk about data sources. And data sources allow you to look up resources that were created either manually or by Terraform, and then return the attributes that are found for that resource. So for an example, let's take VPC, Virtual Private Cloud, data source. Kind of similar structure, right? You know, you have the curly braces, you have what the type is basically, and this is going to be data, AWS VPC, then the local reference to it. So this one, they're going to be calling it selected, and then they want you to pass in the VPC ID. And what this would do is it would return all the relevant data for this VPC, which is, you know, specifically referenced by this exact ID. So data sources can be really helpful in this kind of scenario where you need to pull in information that already exists, you know, some on AWS, or things that will actually be created in AWS. You can use data sources too. Input variables. So input variables are used to provide parameters that you can customize your Terraform module to without altering the source code. So what does that really mean? It means that it prevents you from hard coding values, and unless you have code reuse. So let's take, for example, these code snippets, right? Similar to the resources and data sources, we have variable, and then we have app name. So this is going to be the local reference to this variable. And then you have something that's called a type. So type aligns with standard data types that you might be familiar from programming. And this is a way that you can enforce certain types of data types for the input of your variables. These are broken into categories of primitive types, complex types, dynamic types, and optional types. We'll talk about these in the coming slides. But basically what this is saying in this current code snippet is, hey, I want to make a variable. The local reference is going to be called app name. The type is going to be string, so you can't pass in something like a number. And then you have a description. This is a little bit more for documentation. And then default. Default is really important because this is basically saying if a user doesn't put in a value, then use this as a default. It's important to note that if default is it's optional, but if default is not defined when you actually run your Terraform, you'll be prompted to enter something for the variable. So it's always a good idea to have some sort of a default, just to kind of for error handling and just to make sure that you don't have to type in a lot of variables every time you try to run your Terraform. And then let's see how you can reference this, right? So we have in this a resource, which is an AWS instance. The local reference to it is being called, or the local name within Terraform is app server. And then you can see in these tags block var.appname. So that's how you reference this specific value. So we have variable, so var.appname, because that is what we call the variable. So that's some of how you can use input variables. These kind of map to the in terms of programming, like your standard data types. So things like strings, numbers, Boolean, all that good stuff. And that brings us to types, right? So basic types, primitive types. A primitive type is a simple type that isn't made from any other types. And this is what I was mentioning that kind of correlates to types from other programming languages. So things like a string. So, in this case, hello, that is in quotation marks, that's a string. Number, which is a numeric value. It's important to note that number in Terraform can either be a whole number or it can be fractional values, so like 6.28, etc. And then you have bool, which is going to be Boolean, so either true or false. So it's good for conditional logic. So let's talk about conversion of primitive types. So Terraform will actually automatically convert number and bool values to string values where it's needed and vice versa. But the caveat being the string would have to contain a valid representation of a number or a bool. So in this example, True would convert to true, vice versa. False would convert to false. 15 would convert to 15, and all those being strings. So just something to kind of keep in mind that Terraform will do that automatically where it needs to. Now let's talk about complex types. So a complex type is a type that groups multiple values into a single value. And within these, you have two categories. So collection types would be for grouping similar values, and structural types would be for grouping potentially dissimilar values. So down here, we have an example of a list. If you're familiar with programming in other languages, this would be referred to as an array. And it's basically a sequence of values identified by consecutive whole numbers starting with 0. So in this case, we will have a list of strings because we have a string of A, B, and C. And then to reference the specific values, A would be 0, first element in the list, B would be 1, and then C would be 2. Then we also have maps. Maps are a collection of values where each is identified by a string label. So for this example, we can see this code snippet. We have Naruto Uzumaki, and then within that we have some different fields. So group membership, username, given name, family name, email. This is from a module I made for Terraform module for IAM Identity Center. But you can see in here, right, it's a map, but they don't actually all have to be the same value. So we have some strings in here, but then we also have a list. So that's perfectly fine to do with maps. There's a couple more complex types, and there's some nuances. I can send some more information for the documentation about that, but since this is an intro session, this is as deep as I want to go on that. And then you have output values. So output values allow you to expose information on the resources so that other Terraform configurations can use it. So let's think about it as in this, right? We have an S3 bucket. The local name or local reference we're calling or defining for this is example. We have the actual bucket name as it would be created in AWS, and then we have an output AWS S3 bucket name, and the value is AWS S3 bucket dot example dot id. And this format follows for everything in Terraform that you try to reference, right? You would have in this case, for resources, you would have the resource name, so AWS S3 bucket dot example, because that's what is named here, dot ID, the specific attribute that we want to get from this resource. So you'll see that a little bit more in practice, but just understand this general format. And then we have local values. So local values are named values that you can assign that are assigned and can be used throughout your code. The main difference, because you might be thinking, all right, well, these kind of look like a variable in a little bit. We have, instance name equals something, in this case, a string called dev instance. But the difference being that local values can be constant or reference values. So in a variable, those have to be constant values or something that someone is either going to manually be put in or there's a default or something like that. But in this case, for instance ID, it's not a constant, it's a reference value. So the AWS instance.appserver.id, that's going to actually be the local instance ID. So small distinction, but important. Just recapping that, variables are constant, but you'd have to pass in some kind of constant value, and there's some ways around that, but with locals, they can be reference values. So like this example here for AWS instance. All right. Similarly, you can also use locals with things like the count and the for each that I talked about, but that's a little bit more of an advanced topic. I'll just put that in, in the chat. Now we have Terraform state. I know there's a lot of information that's been presented so far, but if you were, kind of getting lost a little bit, this is definitely what you want to for sure pay attention to. Definitely very important. So Terraform state stores information about your infrastructure within a state file. It's typically named terraform.tfstate, And this is used to determine what changes to make to your infrastructure. So things like what resources need to be added, modified, or removed. And it's your single source of truth for your deployments. This file is automatically refreshed and checked before any other operation is applied. And this is really for checking for drift. So there's additional, some configurations that you can have with state that are a little bit more intermediate to advanced topics. But the main thing that you want to take away, you should never delete this file. Pretty much, especially if you're just getting into it, there's really no reason that you would need to delete this file, as into making modifications to it. The more familiar you get with Terraform, you can make some modifications. So things like maybe importing resources or things like that. But in general, you should not modify this file. It's going to automatically be regenerated, updated, things like that. If you accidentally delete this file, you will have resources orphaned in your account until you have kind of find some kind of way to remediate this. So say you ran some Terraform and you created S3 buckets, IAM roles, EC2 instances, all that kind of stuff, and then you delete your state file. Well, now those files are just there. If you try to run Terraform destroy, which is a command, and we'll touch on all the CLI commands, basically you want to delete all those resources. There's nothing for it to check against because you deleted the file, so it doesn't know what's in the account. So definitely, no, I'm really stressing this, but you do not want to delete this file. If you can probably assume, when I was first learning Terraform, I accidentally deleted this file and I had a bad day deleting all my resources manually. So absolutely do not delete this file. We'll also touch on some ways that you can kind of secure this file. So let's now get into the CLI. This is, kind of one of the main ways that you can interact with Terraform. CLI, or command line interface for Terraform, it can be called with the Terraform command once Terraform is installed on the machine. So if you're using something like Cloud9 and AWS, it actually has Terraform already installed at the time of this video being recorded. That's just native to Cloud9 now. But there are other ways that you can use Terraform. You could run it, in a pipeline. You could have it locally in your own VS Code. But yeah, so you have options. The main commands that you're going to use are init, which will initialize your Terraform working directory, similar to git init if you're familiar with Git workflows. Git init would initialize your working directory as a Git repo. Then you have validate, which would check if your configuration is valid. So this is more for syntax. Plan, this would show changes that are going to be made to your current environment. Apply would create or update your environment, and destroy would then delete the environment that was previously created. And let's zoom in on these a little bit more. So for init, as I said, initializes your Terraform working directory. And this is the first command you're going to run when you're writing a new Terraform configuration or when you clone an existing one. This also relates to modules. When you try to import and use a different module, you also would have to run Terraform init again, because what it basically is doing is performing multiple initialization steps to configure your current working directory to use Terraform. So that can be things like downloading plugins, module configurations, other dependencies. So basically this is a command that you likely only have to run once, but anytime you kind of bring in something that's maybe like a different provider or a different module, that you would have to rerun this initialize Terraform init. Then you have validate. Validate would run checks to verify that the configuration of the working directory is syntactically valid. So basically that your syntax is fine. Your naming is good. You're calling things what they should be called. Your curly braces, or if you have an opening one, you also have a closing one, all that kind of stuff. But it's important to note that this does not validate remote services like remote state and provider APIs. This is purely for just validating that your syntax is fine for your configuration. Common uses, validating reusable modules, and ensuring that names and values for your types are generally correct. It's important to note there's another command that we'll touch on that actually runs this command automatically, but it's just good, especially as you're getting if you're newer to Terraform, to kind of just understand and get in the habit of using this command. Now you have plan. So this would create an execution plan that would provision you with or provide you with a preview of changes that will be made to your infrastructure. And the way it does this is by checking your state file. So remember that terraform.tf state, and it would compare it against your Terraform configuration files to basically determine what the difference is. So, say if you, also it's important to note, if you don't have a Terraform state file, when you run Terraform plan, it's going to actually create that file. So basically what it's going to do is say say, all right, I want to make 3 S3 buckets and, 4 iron rolls. These are the configurations. What it's going to do is it's going to, if there's no, resources already created by Terraform, it's going to say, okay, there's no Terraform state file. And we make that file. And then, all right, well, then in this file, there's no resources already. So I need to make those specific resources that they said they want to have in the configuration. Similarly, once you actually, apply your Terraform and provision those resources, a record of those will be stored in that state file. So then if you need to make a modification or add something else or delete something, it's going to, again, check that state file and say, say maybe you want to add an EC2 instance after that. It'll say, oh, well, they only defined that they wanted, an S3 bucket, an IAM role. Now they want an EC2 instance. This configuration is not in the state file, so we need to make this resource. So again, this really just shows the connection in that state file and how it's that single source of truth. So, if you think, for an example, what would happen if you create a resource in Terraform and then you delete that resource out of your state? If you run another Terraform plan, it's going to say, well, this resource isn't in the state, so as far as Terraform is concerned, it doesn't exist, so I need to create it. So that can really get you in some trouble there. So just really showing the connection between the state file and plan. If no changes need to be made, it's going to return a message in the terminal basically saying no changes will be made. Everything's good. But it's important to note, like I said, we're talking about validate. Plan actually also runs the Terraform validate for you. So you don't actually have to run Terraform validate. When you run a plan, if something is wrong, it will actually throw the error the same way that validate would. So it's good to use validate when you're new, just to kind of understand a little bit more. But in practice, I almost never run validate. I just run plan and then see any errors, which are very helpful in my experience. They really show you line by line, file by file, and even give you recommendations on what they think you were trying to do to help you remediate. So that's about plan. And then you have apply. So apply would execute actions that are proposed from the Terraform plan. The best practices would be to leverage validate and plan prior to running the command to ensure that you're actually deploying resources as you intended. But running Terraform apply, similar to kind of how they kind of would inherently run the other command for plan with validate, running apply would actually run a Terraform plan first. So even if you don't run a Terraform plan, it will run a Terraform plan on its own and subsequently run that validate. And then what it will basically do is prompt you to enter in yes if you want it to go ahead and deploy the resources. But just again, you don't actually have to run plan before apply. It'll do it for you. And then you have destroy. So destroy would delete all the remote resources that are managed by the current working directory's Terraform configuration. So basically, this would be checking that state file and say, okay, well, these are the resources that are in the state, so this is what I need to go ahead and delete. So if you think about it, what if the state file is modified and that resource is not there anymore? Well, then when you click destroy, or sorry, when you enter and run the destroy command, it's not going to destroy the resource. So this is where I was talking about in that scenario where, say you're doing a lab or you're testing something out, you apply the Terraform, accidentally delete the state file, and then you run Terraform destroy. It's basically going to say, I don't have anything to destroy because there's nothing here. It doesn't have that context that the resources are actually still in the account. So that state file, again, I know I keep saying it, but it's very important. That is the most important file, more or less, that you'll have to interact, not really have to interact with, but you just definitely don't delete it. Don't really modify it unless you know what you're doing. Very important file. And that's what I kind of mentioned in that disclaimer. For resources created outside of Terraform configuration, unless you import it into the state, or basically let Terraform know, hey, actually keep track of this too, it's not going to be destroyed even if you run Terraform destroy. Now let's touch on modules. So modules are a way to provide organization to your Terraform configuration, and it empowers the reuse of configurations. So if you think about it, like imagine 3-tier web app, pipeline, stuff like that. What you really wouldn't, say you're in a team environment, you wouldn't want someone to have to define all of the Terraform resources that make all those things up. Maybe your EC2 instances, your auto scaling groups, your IAM roles, all those permissions. Getting with the DevOps methodology, if each time you want to make a new 3-tier web app, you have to define that again, there's still more automation that can be done. So what a module is it basically provides you an abstraction layer, on top of your Terraform resources, data sources, etc., where you can write all the heavy lifting code that makes it really reusable. Then you abstract that away to a couple of variables. So maybe for your 3-tier web app, you have a variable that's the name. Maybe you have a couple of parameters. How many availability zones do you want your EC2 instances to be deployed into? Really makes it easy so you don't have to have everyone redo and reinvent the wheel. Just spend the time, make the module, and then you can just use the module. There's also modules that are public. So if you need to make an AWS VPC, there's a module. There's a Terraform registry that you can go to. You can just use that. And again, the heavy work has already been done. You can just use what you need and define what you need with those variables. You could also have private modules if you're using something like Terraform Cloud, which is a little out of the scope of this being an introduction. Or you could actually just store your modules locally or in a Git repository. So a lot of options, but in short, modules are really what's going to empower you to have reusability for your code and save you a lot of time. Now you might be thinking, all right, well, I'm not using modules right now. I just have my main.tf, my other kind of files. Even if you don't think you're using a module, you are using a module. The main directory that you initialize Terraform in is actually known as the root module. So yeah, modules, everything is going to be based off of sorry about that. Everything is going to be based off a module in Terraform. So root module will be the main one unless you add any additional ones. So as a recap, following the workshop, what you will build is a WordPress application on AWS with Terraform. And yeah, that's kind of an example of it there. So with that being said, let's go build. For those of you who are watching this later, this ends the presentation portion of the section. Feel free to reach out to me if you have any questions. Thanks, everyone.